The diagram shows a speed time graph. Calculate the total distance traveled. In speed time graph, the distance is distance is the area under the graph. So we have to calculate the area of this trapezium, and it is half into height. Height is this much, 12, and then sum of the parallel sides. One parallel side is 15, and the second one is this much, which is 10 minus 3, 7. So just by simplification, it is 132, and as it is distance, and the distance is in meter, 132 meter. So write your answer over here, 132 meter. In the next question, Petra begins a journey in her car. She accelerates from rest at a constant rate of 0.4 meter per second square for 30 seconds. She then travels at a constant speed for 40 seconds. On the grid, draw the speed diagram for the first 70 seconds of Petra's journey. She accelerates from the rest and at a constant rate of 0.4 meter per second for 30 seconds. Please read the statement very carefully. This is 0.4 meter per second square. This is acceleration. And in speed time graph, the acceleration is basically the gradient. That is change in speed over change in time. And then acceleration in the question is 0.4. And we have to find the speed, and the time travel is 30 seconds. Now by cross multiplication, it will be 12 meter per second. So Petra's speed is increasing, and it reaches from 0 to 12 meter per second in 30 seconds. So she will be here in 30 seconds. Because it is accelerating at a constant rate, so the graph will be a straight. She then travels at a constant speed. Constant means same speed for 40 seconds. She has already covered 30 seconds, and she has to move more 40 seconds. So 30 plus 4, 40, 70. So for the next 40 seconds, she will be at a constant speed. So this is her graph of her journey. The diagram shows information about the first 100 seconds of car journey. Here the car is accelerating, its speed is increasing, and then cars start decelerating, and then its speed remains constant. Calculate the acceleration during the first 20 seconds of the journey. In speed time graph, this is the speed is increasing here, then it is in this part there is acceleration. So we have to find acceleration using the gradient, and gradient can be calculated using the rise over run. So here the rise is this much, which is 16. This is rise 16, and the run is 20. So just plug in the value here. Acceleration is 4.5 meter per second square. Next, work out the total distance traveled by the car in 100 seconds. In speed time graph, to find the distance covered, we have to find the area under the graph. So to find the distance covered, we will have to find the area under the graph. So to find the area of this graph, I have divided the graph in 3 parts. The first part is triangle, and the area, the formula is half base into height, and its height is 16 and the base is 20. So the area of triangle is 160, and this is trapezium, and area of trapezium is half into height. The height of the trapezium is the gap between 2 parallel sides. So in this trapezium, these 2 sides are parallel, and the distance between them is 50 minus 20, 30. This is 30. So the height of the trapezium is 30. And then sum of the parallel sides. These are the parallel sides, and the length of this one is 12, and the length of this parallel line is 16. So 12 plus 16. And after simplification, the distance is, the area is 420. The third is rectangle, and the area of rectangle is length into width. Its length is 12 and its width is 50. Area of rectangle is 600, Now just by adding all these three areas will give us the total distance covered in this journey, which is 1180. Therefore, the distance traveled by the car in 100 seconds is 1180 meters. This is the graph of distance time. The diagram shows the distance time graph for the first 65 minutes of a bicycle journey. There are 4 different parts of the journey labeled A, B, C and D. Write down the part of the journey with the fastest speed. So the journey is labeled, this is journey A, the second part of the journey which is labeled B, this is third part of the journey labeled C, and this is fourth part of the journey labeled D. And the steepness of the graph is the gradient, and the gradient is called speed. So we have to see which part of the graph is more steeper. So that part will have, so if you compare all of them, the first part, A part, the line is more steeper. This is the steepest line among all of them. So steepness is basically the gradient, and gradient in distance time graph is speed. So in part A, the speed is the fastest speed. After the first 65 minutes, the bicycle travel at a constant speed of 20 km per hour for 15 minutes. Draw this part of the journey on the diagram. So 65 plus 15 is 80 minutes. So for the next 15 minutes, it travels at a constant speed of 20 km per hour. And we know that in distance time graph, speed is basically the gradient. And gradient is rise over run. I am doing this part of the question in this space. Speed is rise over run in distance time graph. That is gradient or steepness. And it is change in distance over change in time. And just plug in the value. Speed is given in the question, that is 20 km per hour. And we have to find the distance covered, that is change in distance, and the time is 15 minutes. And remember, the unit must be same. Here in speed, the unit is R, but the time is given in minutes. So I will convert this minute into R. So I will divide it by 60 here. So it will be 0.25 here. Now just cross multiply. Change in distance is 5 km. Therefore, for the next 15 minutes, it will cover 5 km. So for the next 15 minutes, 65 plus 15, it will be 80. And it has already covered 23 km. So 23 plus 5, 28. So we will draw a line from this point to this point. So this is a straight line. In next question, the diagram shows the speed time graph of a car. The car travels at 45 km per hour for 20 seconds. The car then decelerates for the 10 seconds until it stops. Change 45 km per hour into meter per second. So to convert kilometer into meter, just multiply by 1000. And to convert R into minutes, seconds, first multiply it 60 to convert into minutes, and then multiply again by 60 to convert that minute into seconds. It will be 12.5 meter per second. Find the deceleration of the car, giving your answer in meter per second square. The car is decelerating in this part. And deceleration is basically a negative acceleration. And to find the deceleration in speed time graph, it is basically the gradient, that is rise over run. The rise is this much, 45, and run is 10. Rise is 45 and run is 10. So it is 45 over 10. But the problem is that we have to give answer in meter per second square. But speed is in kilometer per hour. So we have to convert this 45 km per hour into meter per second, which we have already done in the previous part of the question. Here, and it is 12.5 meter per second. So it is 12.5 over 10. that is 1.25 meter per second square. Find the distance traveled by the car during 30 seconds, giving your answer in meters. Distance traveled is basically the area under the graph in speed time graph. And the shape of the graph is trapezium, so we have to find the area of this trapezium, which is 1/2 into height into sum of the parallel sides. The height is this much, 45 km per hour. But remember, we have already converted into meter per second because we have to find distance in meters. So in meter per second, this 45 is basically 12.5. So the height of the trapezium is 12.5 meter per second, like this. And then multiply by the sum of the parallel sides. One parallel side has length 30 and the second one has 20. 30 plus, after calculation, it is 312.5 meter. Be careful, always be careful about the units. Unit must be same in the calculation. A car passes through a checkpoint at time t is equal to 0 second, traveling at 8 meter per second. It travels at this speed for 10 seconds. The car then decelerates at a constant rate until it stops when t is equal to 55 seconds. On the grid, draw the speed time graph. So car is passing through a checkpoint we took that time t is equal to 0 and the speed was at that time 8 meter per second. It traveled at this speed for 10 seconds. So for 10 seconds it keep on traveling at 8 meter per second. So for 10 seconds its speed remain constant at 8 meter per second. And this is horizontal line. And then car decelerates. Decelerate means speed start decreasing at constant rate. It means the graph will be a straight line. And it stopped when t was 55. This is t 55. Now we have to draw a straight line from this position to this one. So this is the straight line. Because I don't have the ruler, so it is not a very short straight line. So this is the graph. Now calculate the total distance traveled by the car after passing through the checkpoint. So the total distance is basically the area under this graph, and this is trapezium again. And area of trapezium is half into height. Height is the distance between two parallel sides. It is 8 and sum of parallel sides. This one side is 10 and the second side is 55. So 10 plus 50, it is 260. So the total distance covered is 260 meter. Write the unit of distance, not the area. Next question, this is the graph of the next question. Here the speed is increasing and then speed remain constant. The car starts from rest and accelerates for u seconds until it reaches a speed of 10 meter per second. So for u second, this u time is unknown. The car reaches the speed of 10. The car then travels at 10 meter per second for 2u seconds. For the next 2u seconds, the total time will be 3u. Its speed remains constant at 10 meter per second. So this is u and plus 2u will make it 3u. The distance traveled by the car in the first 3u second is 125. So this is very important information. Find the value of u. Distance is given. And we know that in speed time graph, distance is basically the area under the graph. And this graph is trapezium. And the height of the trapezium is 10. So half time height 10 times sum of the parallel sides. The one parallel sides has length 3u and the second one, this one has length 2u. 3u minus u, 2u. So 3u plus 2u, it is 5u into 5u, and it is area under the graph which is equal to the total distance covered, and total distance covered is given here 125. So it is equal to 125. Now we have one equation and we will solve this equation to find u. So u is 5 meter per second. Sorry, u is 5 seconds. So this is 5 and it is 50. Find the acceleration in the first u seconds. In the first u second, to find the acceleration in this portion, basically the acceleration is, in speed time graph, acceleration is the gradient. We have to find the gradient of this portion, which is rise over run. Rise is 10 and run is 5. This will give acceleration 2 meters per second square. The diagram shows a speed time graph of bus journey between two bus stops. This is stop number 1 and this is stop number 2. Hamid runs at a constant speed of 4 meters per second along the bus route. He passes the bus as it leaves the first bus stop. The bus arrives at the second bus stop after 60 seconds. How many meters from the bus is Hamid at this time? Suppose this is the speed time graph of Hamid. Because he is running at a constant speed, his speed remains constant, his speed remains same for the whole journey up to 60 seconds. So this is horizontal line. So when bus started at this time 0, so the Hamid was running at time 0 at 4 meters per second. So at 0 time of observation, both this bus has started the journey from the 0 meter per second, but Hamid was running at 4 meters per second. He passes the bus as it leaves the first bus stop. The bus arrives at the second bus stop after 60 seconds. So now we have to find how much distance bus has covered in this total 60 seconds. And that is the area of this graph, which is triangle here. So we have to find the area of this triangle. And it is half, base is 60 and height is 14. Bus has covered 420 meters in 60 seconds. Now we have to find distance covered by the Hamid. The shape of the Hamid speed time graph is rectangle. And it is length into width. The length of the graph is 60 and the width is 4 because he was running at 4 meters per second. So 60 into 4. So after 60 seconds, Hamid has covered a distance of 240 and bus has covered 420. And there is a gap of 180 meters. So Hamid is 180 meters away from the bus when bus has reached at stop 2. An animal starts from rest and accelerates to its top speed in 7 seconds. It continues at this speed for 9 seconds and then slows down to stop in further 4 seconds. The graph shows this information. Calculate its acceleration during the first 7 seconds. So to find the acceleration here in speed time graph, acceleration is basically the gradient of the graph, that is rise over run. The rise is 14 and the run is 7. So 14 over 7 is 2. Acceleration is 2 meters per second square. Write down its speed 18 seconds after the start. This is 18 seconds and the speed at this time is this one. And we don't know exactly what this speed is. Maybe some of you may guess it is 7. It may be or it may not be. Let's find this speed accurately. Suppose speed over here is v. I just mark v over here. And this is one unknown. For one unknown, we must have one information. Right now, no information is given in the question itself. But we know that acceleration of this line is basically the gradient of this portion of the journey, which is rise over run. Here the rise is 14 and run is just 4. So 14 over. So this is the deceleration in this whole line. And we know that the gradient of the straight line remain constant everywhere. Now we are going to find the gradient of this portion. How much is this much? How much is acceleration in this portion? That is deceleration. And acceleration is same everywhere on this line. Now we are going to calculate the acceleration in this part of the line. Here the rise is v and the run is just 2. As we know that gradient of this line remain constant everywhere, and gradient of this line is acceleration. So acceleration remain constant. Either we calculate the gradient of the whole line or the part of the line. They must be equal. So these two values will be equal. So just by cross multiply or by simplification, v is 7 meters per second. This is important question. So at 18 seconds, the speed was 7 meters per second. This is the accurate speed at this point of time. Calculate the total distance that the animal traveled. The total distance is basically the area under this graph. And the area of this graph is, it is trapezium. So try it yourself. The answer is 203 meters. Verify your answer yourself. The graph shows the speed of a sports car after t seconds. It starts from rest and accelerate to its maximum speed in 12 seconds. Remember, this is speed time graph. Draw a tangent to the graph at t is equal to 7. Here the difference of the time is from 5 to 10, 5 seconds, and there are 10 boxes between them. So we have to see how much one small box represent. So for 5 seconds there are 10 small boxes. 5 to 10 there are 5 seconds and there are 10 small boxes. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. And I want to know how much this one box represent in seconds. So for one box, how much time it represent? So now cross multiply, it represent half second. So it means that 2 boxes represent 1 second. So 7 will be 5, 2, 6, and here after 4 boxes, this is 7 second here. So we have to draw a tangent line. So t is equal to 7. Go vertically up. It will touch the graph over here. Now we have to draw a tangent line at this point. And tangent line is a straight line that touches the graph at only one point. This is the tangent line. Now we have to find the gradient of this tangent line. Find the acceleration of the car at t is equal to 7. It is speed time graph, and the gradient, we have to find the acceleration at t is equal to 7. To find the acceleration at t is equal to 7, basically we have to find the gradient of this tangent line. So we have to find the gradient of this tangent line just taking the rise over run. Take any 2 points of this straight line, wherever you like. Let me take this point and draw the rise, and this is the run. So this, how much is this rise and how much is this run? Here it is 20 meter per second gap. This is 10 meter per second gap, and it is divided by 5 boxes. 1, 2, 3, 4, 5 boxes. So 10 divided by 5. Again, this 10 gap of 10 is divided by 5 small boxes. So 10 divided by 5, 2. So one small box represents 2 meter per second. And at this point, where this 7, at this point, it touches over here. It is 20 minus 2, 18. So the rise is 18. And how much is the run? We know that on x-axis, one small box represents 0.5 seconds. And these are 8 boxes. So it represents 4 seconds. So this is 4. So rise is 18 and run is 4. So acceleration is 4.5 meter per second. And it was the gradient of this line. And gradient of the speed time graph is acceleration. Now it is 4.5 meter per second squared. The car travels its maximum speed for 13 seconds. Find the distance traveled by the car at its maximum speed. So distance traveled is basically the area under the graph. Now we have to find the distance of that part of the journey where the car traveled at its maximum speed, and that is for 13 seconds. The car was running at maximum speed at this portion. So it is from here. So it is given in the question, it is 13 seconds. So a car remained at maximum speed for 13 seconds. No need to calculate it accurately here because it is given in the question. It is 13 seconds when its speed remain at maximum. So from this portion, the shape of the graph is rectangle. So we have to calculate the area of this rectangle. So the one side is 13 and the second side is 60. So 60 into 30, that is 780 meter. So the distance covered in this portion is 780 meter. The graph shows the speeds of two cyclists, Alonso and Boris. Alonso accelerated to 10 meter per second, traveled at a steady speed, and then slowed to a stop. Boris accelerated to his maximum speed v meter per second and then slowed to a stop. Both cyclists traveled the same distance in 16 seconds. Calculate the maximum speed for Boris. Show all your working. You can see here we don't know the maximum speed of the Boris. So there is only one unknown. We must have one information in the question, and that is given in the question. That is that the both cyclists traveled the same distance at 16 seconds. So we will calculate the distance of both of them. It is trapezium. So we have to calculate the area of this trapezium because we know that in speed time graph, area is basically the distance covered. So the area of this one is, just finding the area of trapezium, it is 130 meter. So the distance covered by Alonso is 130 meter. And the area of triangle is half base into height. Base is 16 and this is the height, which is V, not given in the question, V. So the area of this triangle is 8V meter. Therefore, distance covered by the Boris is 8V. And according to the question, both travel the same distance in 16 seconds. So the area of the both of the diagram will be equal. Therefore, 8V will be equal to 130. So V will be 16.25 meter per second. Therefore, the maximum speed of Boris will be 16.25 meter per second. The next question, the graph shows the speed of a truck and a car over 60 seconds. This triangle is the graph of the car, and you can observe here there is a horizontal line. Let me color this. This red line is the travel graph of a truck. Here the speed remains constant everywhere. We have to calculate the acceleration of the car over first 45 seconds. So we have to find the gradient of this portion of the car, that is rise over run. So it is, the height of this is 36. Okay. So because there is a gap of 10, 30 to 40, it is a gap of 10. And this gap is divided by the 10 small boxes. So 10 divided by 10 is 1. So one small box represents 1 meter per second. So there are 6 boxes here. So it is 36. And the run from here to here, it is again one small box represent 1. 1, 2, 3, 4. It is 44. It is 9 or 11 meter per second square. Sorry, it was 45 seconds. So it is 45. So let me do the calculation again. It is 4 or 5 meter per second square. Calculate the distance traveled by the car while it was traveling faster than the truck. Look here. Here the speed is increasing. The speed of the car is increasing from 0. But the truck was just moving 12 km per hour at the time when we observed this car and truck. At the start of our observation, the car just started, but truck was moving at 12 meter per second. So in this portion of the journey of the car, the speed of the car is less than the speed of the truck. But after this point, the speed of the car is greater than the speed of the truck. And it remains greater than the speed of the truck up till this point. And here, at this point the time is 15 seconds, and at this point the time is 55 seconds. Now we have to find the area in this portion, and remember, find the total area up till this x-axis. Find the area under the graph up to x-axis, and don't get confused. To find the area of this triangle only, you have to calculate the area of this rectangle also, and then add both of them to find the total area, and that area will be the distance covered by the car when its speed was greater than the speed of the truck. To find the area of this whole portion, we have to find the area of this triangle and this rectangle, and the base of this triangle is 55 minus 15, that is 40, and this is the height of the triangle. The total height, the length of the line from x-axis to this point is 36, and this is 12. This is 12. So 36 minus this 12, because it is 12 here. So the total length is 36, and subtract this much length, which is 12. This is 12. So 36 minus 12 will give you the height of this triangle. That is 24. No, the height is 24. So the area of the triangle is 480. Now we have to calculate the area of this rectangle. Here it is 40 and it is 12. 40 into 12. This area is also 480. So the total distance covered is 480 into plus 480. That is 960. So the distance covered by the car when its speed was greater than the speed of the truck, it is 960 meters. An athlete in a race accelerates to a speed of 12.4 meters per second in 3 seconds. Look here. In 3 seconds, it is accelerating. Its speed is increasing. He runs at this speed for the next 5 seconds and slows down over the last 2 seconds as shown in the speed time graph above. He crosses the finish line after 10 seconds. So the total time taken is 10 seconds, and at this time he crosses the finish line. The total distance covered is 100 meters. So this is the information which is given here, which is not mentioned in the diagram. So I underline it. Calculate the distance he runs in the first 8 seconds. This is 8 seconds. So how much is the distance covered in first 8 seconds? That is the area up till this time. So at this point in time, the figure is trapezium. It looks trapezium. So area of this trapezium is half, and the height of trapezium is 12.4, and the sum of the parallel sides. This side is 8 minus 3, that is 5. This length is 5, and this is 8. 8 plus 5 is 30. So the distance covered is 74.4 meter. Remember, use the distance unit, not the area unit. Sorry, it is 80.6 meter. Calculate his speed when he crosses the finish line. He crosses the finish line over here. And now we have to find what speed was at this point. You may guess that it may be 6, but we are not sure. It may be 6.1, 6.2, or maybe 5.9, 5.8. So we are not sure what accurate speed it is. Now we must have any information in the question to find this one unknown, and that is this information, that the total distance covered is 100 meter. Now we will find the total area, and for that we will split this figure into two parts. This is trapezium and this is also trapezium. We have already calculated the area of this trapezium, which is 80.6. Now we have to find the area of only this trapezium. Here, this one and this one is the two parallel sides. Let me mark here, just for your understanding. And the distance between these two parallel sides is 2. And this is the height of the trapezium. Let me write 2 here. And then sum of the parallel sides. This side has height 12.4 and this has height v. So 12.4 plus v. This will give us the distance covered in this portion. This 2 will cancel out with this 2, then we left this 12.4 plus v. So the sum of the distance of this one and this one will be equal to the total distance, or total distance covered, and that is 100 meter. So the sum of this one, these two will be equal to 100 meter. Once again, area of these two portions will be the total distance covered, which is 100. Now we have one equation. Now we will solve this equation to find v. It is v plus 93 equal to 100, and v is 7 meter per second. But from our observation, it looks that it could be 6.2, but it is 7 right now. So we have calculated this v, which is 7 meter per second. The graph shows the distance in kilometer of a train from Hilltown. Find the speed of a train in kilometer per hour at 8:30. So what will be the speed at 8:30? Suppose it is v here. And we know that in distance time graph, speed is basically the gradient of a line. So, and we know that the gradient of straight line is always constant. Wherever you take the gradient, it will remain constant. It will remain same. So speed is same everywhere. So either you take the gradient of the whole line or the part of the line, you will get the same answer. So to find this v, that is the gradient of the line, we will calculate the gradient of the whole line, which is rise over run. And this is the rise, and the total length from here to here is 120, and this much is 40. So we will subtract 40 from this 120 to get this much length, which is 80. So the rise is 80. Now how much is the run here? First of all, see here. The distance from here to here, it is 30-minute gap. 8 o'clock and 8:30. It is 30-minute gap. And this 30-minute gap is divided by how many boxes? 1, 2, 3, 4, 5, 6 boxes. So 30-minute is divided by the 6 boxes. So 30 over 6, 5. So this one box represents 5 minutes. Okay. So from here, it is 30, 35, 40, 45 and 50. So this is 50 minutes. And we have to calculate the speed in kilometer per hour. So we have to convert this 50 minutes into hours. So divide it by 60. So it is 5 over 6 hours. Okay. and the speed is the gradient of this line. So rise over run 80 divided by 5 over 6, and this is 96. So speed at 8:30 is also 96 kilometer per hour. Now we have to find the speed in kilometer per hour at 9 o'clock. At 9 o'clock it was over here, and you can know that in a distance time graph the speed is the gradient, and gradient is steepness. Here the steepness is nothing, zero steepness. It is horizontal line. So when steepness is zero, the speed is zero. So the speed is zero everywhere on this horizontal line. So at 9 o'clock, speed will also be zero. So it will be 0 kilometer per hour.